So let's jump into an example problem off of the last video we learned about pedigree charts. So this is going to be an example. It says here's a pedigree chart for a family for the type of eyebrows trait. All right, so we're looking at type of eyebrows. All right, bushy eyebrows are completely dominant to thin eyebrows. Notice it tells you what type of trait it is, completely dominant. If it was codominant, it would have to tell you it's codominant. If it's sex-linked, it would have to tell you that it's sex-linked. And so this becomes powerful information. So if it's completely dominant, we know we're dealing with one capital and one is a lowercase. Typical type of genetics problem. All right, so I'm going to pick a letter. Again, define your letters. I'm going to go with capital B and lowercase b. Makes it easy. All right, which one's going to be on the capital? Is it going to be bushy or thin? Bushy is dominant, so bushy would be on the capital. Thin would be on the lowercase. Okay. And so then you go, okay, the thin is going to be the shaded one because it's the recessive. So I've got a couple of options here. We'll get to these in a second. But basically, I could have a circle that's not shaded and a circle that is shaded. And I could have a square that's not shaded and a square that is shaded. So the shaded ones are really easy because if they are thin, the only way to have somebody that's thin, remember you gotta have two copies of each piece of DNA, so one from mom, one from dad, right? So this person would have to be little b, and this person would have to be little b. So the shaded are really easy to figure out. The ones that are not shaded, not so much. You know that they have to have at least a capital B to be bushy. These are bushy. Okay, so these are thin. These are bushy. But that second letter is a mystery. Could be capital B, or they could be a carrier where they're capital B lowercase. So you don't know which one it is. Sometimes I write it as B and then question mark, or B with just a line because I know I got to fill that in later. And so as you go through your pedigree chart, where do you start? You start with the shaded ones because it's real easy to see that if it's shaded, it's obviously lowercase. So let me give you an example here. We're going to try and go through and figure out everybody's genotype. So if I was going to go through and write everybody's phenotype, this has got, Carlos has thin eyebrows, bushy, 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 bushy. He's thin because he's shaded, and bushy eyebrows. Okay. So now let's figure out their genotypes, the letters. Start with the shaded. Those are the easy ones. All right, so Carlos, he has shaded in, so he must be little b. Easy. Same thing with Joe. In fact, I got those mixed up, didn't I? Joe's not a girl. That should be Mary. And let's make that Joe, shall we? All right. So Mary should be little b. Okay? Everybody else, you know, has to have at least one capital B. You don't know what the second letter is, but they have to have at least one, because otherwise they wouldn't be bushy. Okay, so here's how it works. Carlos, if he's little b, that means he got one of these from his mom and one of these from his dad. So these people are his sisters. Adrianna and Lizzie are Carlos's sisters. He doesn't get his DNA from his sisters, he gets it from dad and mom. Well, they both gave him a little b. So that tells you that Dominique, his dad, must have had a little b in order to give it to Carlos. And Nancy, his mom, must have had a little b to give it to Carlos. So boom, we just figured out what they are right there. Okay. Now, Nancy, Julio, Cassandra, and Steve are all brothers and sisters from Joe and Mary. So if Joe and Mary gave birth to all these kids, you say, all right, well, let me look at this. The parents, Mary is little b. So the only thing Mary could give to any of her children is a little b. So obviously she gave that little b to Nancy, but she must have also given a little b to Julio and to Cassandra and to Steve. So that means that the big B must have come from their dad, Joe. Big B, big B, big B, big B. Now, here's the thing. I can't guarantee it, but if he gave a big B 4 times out of 4 times, that's pretty much 100%. So the only way he could be guaranteed give it every time is to say he's probably big B. But that is a question mark. That's not guaranteed. But that seems unlikely because he gave it to 4 children every single time. Because they didn't get their big B from Mary, they must have gotten it from Joe. That's from mom, that's from dad. That's from mom, that's from dad. That's from mom, that's from dad. Okay. So now we got everybody up there pretty much sorted out. Let's come back over here. Okay. So here's the situation. Adrianna, this is her dad, this is her mom. She got a big B. She could have got that big B from Dominic, which means that her mom could have either given her a big B or a little b. So we don't honestly know what she has for that second letter. Lizzie, same situation. She got a big B. Could have been from dad, which means mom gave her a big B or a little b. Or she could have got this big B from mom, which means dad gave her a big B or a little b. So we do not know for certain what that second letter is. And so sometimes in a pedigree chart, you might look at it and you go, look, I just don't know what that final answer would be. But I can tell you that one of them is a big B. I just don't know what the second one is. And that's totally legitimate to do. Now, if Adrianna, let's just say, went and got married, had a kid, and the kid ended up shaded, well, then you know that to be shaded, that kid would have had a little b, little b. Move this up. So Adrianna got married, I don't know, let's call him Mark. And they had a daughter named, Julia. Julia must be little b because she's shaded. So then that tells you Adrianna, it's not a question mark anymore. She must have had a little b in order to give one of those little b's. And the other little b came from Mark. And if he's not shaded, that tells you that he must be that. And so in pedigree charts, there's a lot of like looking around. You look at the parents, you look at the kids, you look at the siblings, you look at their kids, and you just kind of go, well, that came from there, and that came from there, and that came from there. And you kind of work backwards, forwards, all sorts of different directions to figure out what all the letters are. And that's how we did it right here. All right? All right, let's go with one more problem. And this one is actually off of the extra credit. Okay. So it says, here's the pedigree chart for your investigation and the extra credit assignment. The pedigree chart is for a family showing the effects of hemophilia, which is a sex-linked recessive disorder. Okay, a lot of information in there. First of all, it's sex-linked. Okay, so that should be ringing a bell, going ding, 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 ding. That means you got X and Y. It's recessive, so that means you only have hemophilia when it's a lowercase letter. Okay, so a lot of figuring out here. I want to do the letters on the side this time, a little more room. So I know that there's X, there's another X, and then there's Y. There could be an X with a capital R, there could be X with a lowercase r, and then Y has nothing. Okay? Since hemophilia is recessive, it tells you that, that means it goes on which one? The capital or the lowercase? The lowercase. So this is hemophilia. So what is the capital? Typical. Sometimes people say normal, but we don't really believe there's any normal. Typical means not hemophilia. And so then what's on the Y? Nothing. Y chromosome, remember, is really short, doesn't have very much DNA. Okay. So we're dealing with a sex-linked trait. That's why we had to have the X's and the Y's. And then the capital and the lowercase go on the X. Nothing goes on the Y. And the reason we knew hemophilia was with the lowercase is because it told us hemophilia is recessive. Recessive means lowercase. Okay, so let's go look at the pedigree for this family. All right, so we got grandma, grandpa, grandma, grandpa. Grandpa Dave and Grandma Lucia had 3 boys. One of their boys, Joseph, married Olivia, had a son named Mason. Their other son, Michael, got married to Adrianna. They had 2 girls, Zoe and Emma. Grandpa Luke and Grandpa Grace had a girl and a boy. And the shaded means they have hemophilia. So let's just make sure we go with that. Shaded equal hemophilia. Because it's recessive and it's a disease. And usually the shaded represents the disease. Okay, so where do we start when it's sex-linked? You start with the sexes. You start, okay, let me just go with X's and Y's. So if this is grandpa, to be a boy, it's got to be X, Y. Grandma, X, X. Grandpa, X, Y. Grandma, X, X. Olivia is a girl, XX. Joseph is a boy, XY. XY. So 3 boys, a girl, a boy, a girl, a girl, a boy. Okay? That's probably the easiest thing to get done first. So just go through and say girls are XX and boys are XY. All right, now if you're shaded, you have hemophilia, so you have the lowercase. So if you're a boy, you only need on 1X. If you're a girl, in order to have hemophilia, you'd have to have it on both X's. Okay, so boy, 1X, boy, 1X, boy, 1X, girl on both, girl on both. Okay, now let's go to the non-shaded ones. The non-shaded ones are typical. And so in order to have that, you have to have at least one capital R. So if you're a girl, like Emma here, you know that one of them is a capital. You don't know what the other one is yet. Adrianna, she's a girl. One of them's a capital. You don't know what the other one is yet. Isaac, since he's a boy and he only has 1X, that 1X has to be a capital. Same thing with Grandpa Luke. He's not shaded, so that means his X has a capital and the Y has nothing. Same thing with Grandpa Dave. His must be a capital. And Olivia has 1 capital, but we don't know what the second one is. So we're almost done here if you think about it. I mean, done, 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 done. Still need to figure that one out. Done, done, done. Need to figure that one out. Done, done, and need to figure that one. So we only have 3 people we need to figure out, which is Olivia, Adrianna, and Emma. Okay? So then we go, okay, let me do some thinking here. Zoe is the daughter of Adrianna. Zoe got a little R. Well, she could have got the X with the little R, one of them from her dad, Michael, but she must have got this other one from her mom. Well, her mom has a capital, so that tells you the other one must be lowercase. So that takes care of that. Then over here you look at Emma. Emma got an X with a capital R. She obviously didn't get that from dad because dad only has an X with a little r. So she must have got that X with a little r, capital R, from mom. So then this other X must have come from dad. Well, dad only has 1 X to give her, the X with the little r. So that tells you that Emma must also have a little r. She got that from dad. Olivia, okay. So I don't know anything about Olivia's parents, but I do know she had a kid named Mason. Mason gets his Y chromosome from dad, right? So that means he must have got the X chromosome from mom. His X chromosome has a little r on it. Mom so far only has a capital R, so that tells you the other one must be a little r. And there you go. And now we know the genotypes of everybody in this family. And so what it tells us is that Emma is a carrier, which means she has half of the disease, she's carrying it. So is Adrianna, she's a carrier. And so is Olivia. So they are carriers. So they could potentially have children with hemophilia, even though they don't themselves have hemophilia. This is the kind of information we can learn from doing these pedigree charts. All right, so the couple questions you have, I'll help you with those. It says fill in the missing phenotypes for Adrianna. We did that one already. Adrianna, right there. She's X capital, X lowercase. So X capital, X lowercase. Isaac. Isaac was right here. Isaac is X to the capital and a 1. And then number 8, based on the pedigree given, who are the potential suspects? Okay, so I go back up to my suspects. For hemophilia, the person had to have hemophilia. So in this one, it's real easy. All the shaded people are the suspects. So who could it be? Could be Grandma Lucia. Oh no, not Grandma Lucia. Could have been Grandma Grace. Oh, look at the grandmas committing crimes. See, who else could it have been? Joseph, Cameron, Michael. Joseph, Cameron, Michael, and Zoe and Mason. And you're saying, where do I get that list from? Well, it says, who are the potential suspects? I know that the suspect was positive for hemophilia. So everybody that's shaded has hemophilia. So I just listed all the people who are shaded. And so then I go look at the other chart, because you're getting another pedigree chart for blood type, and you're getting another pedigree chart for bent thumb, and then you're going to list the suspects, and the same name that appears here and appears in those will be the person who did it. So you're looking for somebody whose name comes up in all 3 pedigree charts, and that is the person who did the crime. All right. So that is how you solve pedigree charts and solve the questions associated with your extra credit assignment for this final week. I hope you feel like you've learned some genetics. It's really valuable stuff to know, especially when you start having kids of your own one day. And I wish you good luck. Again, if you have any questions on these things, please reach out to me through text message, Jupiter message, or you can email me. All right, good luck, everybody.